Welcome to Future Forward, where we explore breakthrough technologies. Today, we're diving into the incredibly small world of nano-3D printing and its monumental impact on superconducting materials. Imagine creating complex, three-dimensional structures, smaller than a human hair, that can conduct electricity with zero resistance. This isn't science fiction, it's the reality of 3D nanoprinting. For years, making superconducting materials, especially in intricate 3D shapes at the nanoscale, has been a huge challenge. Traditional methods like lithography were mostly stuck in 1D and 2D, think wires and thin films. But things are changing. An international team, led by researchers at the Max Planck Institute, recently developed a nano-3D printing technique to create these tiny superconducting structures. What's truly amazing is their ability to control the superconducting state locally. They can even switch these nanostructures on and off by simply rotating them in a magnetic field. This means we're looking at reconfigurable superconducting devices, a massive leap. Shifting from 2D to 3D at this scale allows us to tailor how materials behave by adding curves, breaking symmetries, and creating interconnected pathways. Several innovative techniques are making this possible. For instance, focused electron or ion beam induced deposition, or FIBID, uses these beams to deposit material with incredible precision, building things like nanohelices. Another fascinating method involves DNA self-assembly. Scientists use DNA origami as a tiny scaffold to build 3D shapes, coat them with a superconductor like niobium, and then remove the DNA, leaving a pure 3D superconducting nanostructure. There's also ink-based 3D printing approaches, like one from Northwestern University and Fermilab, where they print a shape with special ink and then convert it into a single crystal superconductor, which boasts superior electrical properties. So, what can we do with these nano-3D printed superconductors? The potential is vast. Think about quantum computing and sensing. These precisely engineered structures are crucial for developing advanced qubits and highly sensitive magnetic field sensors. This could revolutionize medical imaging, like MRIs, and even geological surveying. We could also see more powerful magnets for particle accelerators and other scientific tools. And for everyday life, this technology could lead to low-loss power transmission and advancements in things like maglev trains. The ability to create complex, high-aspect ratio metal structures opens new doors for miniaturized electronics, especially for future communication technologies like 5G and 6G. Of course, there are still challenges. Ensuring material purity and consistent superconducting properties at this scale is tough. Researchers are working hard to refine these printing processes, find new materials, and develop ways to test these tiny 3D structures. In short, nano-3D printing of superconductors is a rapidly advancing field. It's where materials science, nanoscale engineering, and physics meet to create devices that could transform technology as we know it. The control we're gaining over design and function at this tiny scale is truly exciting.